Hello students, myself Jannavi Gore. In this video of the application of derivative part 2, we are going to study about the first, that is approximation of the values or the use of derivative to find out the approximate value and maxima minima. Approximation. The word itself says that we try to find the approximate value for a given function. For that, if the function f is from D to R, where D is a subset of R, be any function given by y is equal to f of x. As y is a certain function of x, y depends upon the x. As there will be small change in the value of x, it will show the change in the value of y. And so delta x will be denote a very small change in the value of x. There will be small change in the value of y. And that change will be denoted by delta y. Now delta y will be f of x plus delta x minus f of x. We'll call this as a equation number 1. Now we know that delta y will be depends upon the change in the value of x, so that is the delta x, and the rate at which y is changing with respect to x, and the rate of y changing with respect to x is given by dy by dx. So we get delta y is equal to dy by dx into delta x. Dy by dx can also be written as f dash of x. So we get delta y is equal to f dash of x into delta x. Now we will replace this value of delta y in equation number 1. And what we will get is f dash of x delta x is equal to f of x plus delta x minus f of x. And therefore f of x plus delta x is equal to f of x plus delta x into f dash of x, where delta x is very small compared to the x. So whenever we know the function, and if you want to find out the value of x plus del x or delta x, can be written as f of x plus del x into f dash of x. If it is a minus sign, then that means the value of delta x is a negative. So we can replace that value. Now to understand this, we will take one more example so that we will come to know about this approximation, how we can use this. Now we will take an example. Using the differentiation, find the approximate value of 15 raised to 1 by 4 up to 3 decimal places. Now as it is a 15 raised to 1 by 4, our function will be x raised to 1 by 4. So f of x is x raised to 1 by 4. Naturally, what will be its derivative? That is f dash of x. By the formula of x raised to n, it will be 1 by 4 x raised to minus 3 by 4, or we can write 1 upon 4 x raised to 3 by 4. Now as we want to find out the 15 raised to 1 by 4, first we will try to get a value such that its fourth root can be calculated easily. Now 16, we know that fourth root of 16 is 2. So this f of 15, we will write it as a f of 16 minus 1. So here your value of x becomes a 16 and delta x becomes a minus 1. And delta is should be very small. Then we know the formula. F of x plus minus del x is f of x plus minus del x into f dash of x. So your value of x is 16. Now as we required f of 16 and f dash of 16, we have calculated f of x, f dash of x. We will calculate now f of. So what will be f of 16? 16 raised to 1 by 4. 16 can be written as 2 raised to 4, and so f of 16 will be 2. Now we will try to find out the value of f dash of 16. That will be 1 upon 4 into 16 raised to 3 by 4. 16 is 2 raised to 4 raised to 3 by 4. So 4 will get cancelled. That will be 2 raised to 3. And 2 raised to 3 is 8. So we get that is f dash of 16 is 1 upon 4 into 8. And that will be 0.03125. Now f of 16, we have studied f of 15 will be f of 16 minus 1 f dash of 16. Now replace the values. 2 minus 1 into 0.03125, and when we simplify we get 1.96875. So we have calculated approximate value of 15 raised to 1 by 4 as 1.96875, and for that we have used the derivatives. Now, so using these derivatives, we can find out the approximate value for any function. Now we will understand, or we will solve one more question. We have taken the question number 3. Find the approximate value of f of 5.001 when f of x is given x cube minus 7x square plus 15. Now in this case, as we required f of 5.001, that means actually every x should be replaced by 5.001. That will not be possible, or it will be very now for that, as we required 5.001, first what we can write, f of 5.001 is f of 5 plus 0.001. So your x is 5 while del x is 0.001. By the formula it will be f of 5 plus 0.001 f dash of 5. For that first we'll calculate f of 5. F of x is given. So to calculate f of 5, every x should be replaced by 5. So that will be 5 cube minus 7 pi square plus 15. So that will be 125 minus 175 plus 15. We get it as a minus 35. Now f dash of x. What is the derivative of 3x cube? Will be 3x square minus, this will be 7 2s of 14x, and derivative of 15 is 0. So we get f dash of x as 3x square minus 14x. So f dash of 5 will be equal to 3 into 5 square minus 14 into 5. Ultimately, after simplifying, we get it as a 5. Now we will use the formula. F of 5.001 is f of 5 plus 0.001 into f dash of 5. So replace the values. That is a minus 35 plus 0.001 into 5, and when we simplify we will get it as minus 34.995, and so we get that is f of 5.001. This is approximate value. Otherwise replace 5.001 here, make it cube, it will be the tedious job, and for that we use this to get the approximate value. This value is not exact value but will be the approximate value. Now the next, maxima and minima of the function. Before this we have studied what is mean by increasing function and decreasing function. When the first order derivative is positive for certain values of x, we say that the function go on increasing, and when the first order derivative is negative, it indicates that the function is a decreasing function. Now for the maxima and minima, first we should find out the critical point. Now what is mean by a critical point? A point C in the domain of the function f for which f dash of c becomes a 0. So first order derivative compared to the 0, try to get the value of c, and this c is called as a critical point, or if f is not differentiable at c, then also the c is called as a critical point. So first for the maxima and minima, we require to find out the critical point. After this, now we'll try to understand with this plot. That is a graph. What happened here? This curve shows that it has gone on increasing from this side. When I start from the negative part of this is go on increasing, increasing, increasing. In L also it goes on increasing, and up to the point M it goes on increasing. But after the next point to the M, at the M till point M it was going on increasing, but when we go to the next point of M, the function has started decreasing. So such function where we are just saying that this is a increasing, so from left side of the point M my derivative was positive, while from the right side of the point M, immediate next point, so that is a called as a close to M, the next point close to M, the value of dy by dx will go on decreasing, and in such case this point M will be called as a local maximum point, and the value of this M or value of this point, value of f of x at this point is called as a local maximum value. So for the local maximum value, the first derivative test, there are two types, first derivative test and second order derivative test. In the first order derivative test, we have to check first the dy by dx go on increasing, increasing up to certain point, and after that point it starts decreasing. Then that point is called as a local maximum value, or that is a point is a local maximum point. While in this another graph, what the same graph, what happened? As it is started from M, it goes on decreasing, decreasing, and at P also it was a decreasing. So what happened? The value of dy by dx was a negative up to the point Q. But next to the point Q, it has started again increasing. That means dy for the point Q, for the left of the point Q, my value of dy by dx was negative. But for the right of Q, the value of dy by dx will be the positive. And so this point Q is called as a local minimum point, and the value of f of x at this point of Q is called as a local minimum value. So from the graph it's very easy to understand, because from graph we can see that this point go on increasing and from this started decreasing. So that is a maximum point what we get here. While in this case it has was decreasing, decreasing up to the Q, and after Q it has started increasing, and so that is a local minimum point. And this is all order derivative test. Now for that, it is defined as f be a function defined in the open interval of I, and let f is a continuous. So that is a required, the function should be continuous. Again naturally it should be differentiable, then only we'll get a critical point. C is a critical point, because what is a critical point? F dash of C should be 0. So function should be defined in the certain open interval, is continuous and differentiable, and C is a critical point in I. Now there are three conditions after that. The first, if f dash of x changes sign from positive to negative as x increases through the C. It means initially it was a positive, it means it was increasing function, and from that next to the C it has become the negative, it means it goes on decreasing function. That is, f dash of x was a positive at every point sufficiently close but left of C, and f dash of x becomes a negative at every point close to C but right of C, then C is a point of maxima. That only what we have studied from the graph. The M was a point of a maxima, and that is called as a local maxima. While the second, now it's a reverse. F dash of x changes the sign from negative to positive. It means initially the dy f dash of x was a negative up to the point C, which is a left to the C. Up to the left of C point, it was a negative. And from the right point to the C, it becomes a sufficiently close to C, but the f dash of x becomes a positive. Then This point C is called as a local minimum. In the graph, we have seen that in the point Q, correct? Up to the point Q, it was a decreasing, but next point to the Q, it was go on increasing. And so this point is called as a minima value, or that is called as a local minima. If f dash of x does not change the sign, that through the x increases, though our x increases, f dash of x sign remains the same. If it is a positive, will remain the positive, and if f dash of x is negative, it is going to be remain the negative. Then that point is not a local maxima and not a local minima. So such C point is neither a point of local maxima nor a point of local minima, and such point is called as the point of inflection. So there are three parts. We can find out the point of maxima, local maxima point, local minima point, and certain points are maybe there which is not increasing, decreasing, and such point is called as a point of inflection. This what we call the maxima and minima are called as a local maxima and local minima. Now whenever the function is given in the certain interval of a and b, that is in the interval of a and b. Now in this interval we get a c, point c, such that f dash of c is 0. We have calculated all the values of f of c for all such values of c. We'll calculate f of a as well as f of b. So for this f of c, what we get, it may be the local maxima, minima. Along with that, we are calculating the value of f of a and f of b. And the maximum value among this f of a, f of b, and all f of c. We may get the value of c or 1, 2, that depends upon the function. It's called as a absolute maximum value. So local maximum and absolute maximum are different. Local maximum point gives you the point at which the function becomes a maximum. While for the absolute, in the interval of a to b, we'll calculate f of a, we'll calculate f of b, and all f of c. And what is a maximum among all these values is called as a absolute maximum value, while the minimum among all these values is called as a absolute minimum value. So we can find out the local maxima minima as well as we can find out the absolute maxima minima. But absolute maxima minima, we should know the interval a and b. If it is interval is not given, we cannot find out the absolute value. Was the first derivative test. Now we will go for the second test. The word second order derivative or second derivative test is a second order. It means we have to differentiate up to the second order derivative. Now f be any function in the interval of I, c is belongs to I, and f is twice differentiable at c. So then we get first x equals to c is called as a point of local maxima if f dash of c is 0 and f double dash of c is negative. Here exactly opposite, when it is a negative, you have the maximum point, or that is called as a local maxima, and the value of f of x is a local maximum value of f. Now this is the first. Second, x is equal to c is a point of minima if f dash of c is 0 and f double dash of c is positive, and the value of f of c is called as a local minimum value of f. The third, if test will fail if f dash of c is 0 as well as f dash of f double dash of c is also 0. Now what it mean by, whenever the function is given, first we'll find out its first order derivative compared to the 0 and try to get the values of c. Depending upon the function, we may get one or two values of c, and for every value of such c, we'll find out its second order derivative. And if second order derivative is a negative, it indicates that it is a local maximum. If second order derivative is positive, it indicates that it is a local minimum point. And if f double dash of c becomes a 0, actually no maxima, no minima, or this test cannot say which is a maximum and minimum value. And when second order derivative test fails, we have to find out the local maxima and minima point or the point of inflection by the first order derivative test only. So that is a second order derivative test becomes easy to solve rather than the first order derivative test. Now to understand this, we will go with one of the examples. Find both maximum value and the minimum value of the function 3x raised to 4 minus 8x cube plus 12x square minus 48x plus 25 in the interval of 0 to 3. Now as the intervals are given 0 to 3, we have to find out the local maxima minima as well as we have to find out its absolute maxima and minimum value. Now for that, as the function is given, first we will find out its first order derivative. Now what is the first order derivative? That will be 12x cube minus 24x square plus 24x minus 48. Now immediately we will calculate its second order derivative. What will be f double dash? That will be 36x square minus 48x plus 24. Now f dash of x is equal to 0 because we require the values of c, that is the critical points, such that f dash of c should be 0, or we'll directly write f dash of x is 0. So what we get, 12x cube minus 24x square plus 24x minus 48 is 0. We have taken 12 common and we get x cube minus 12x square plus 2x minus 4 is 0. We'll try to factorize this. We'll take x square common. We get x minus 2 plus 2 common, x minus 2. So splitting, we get it as x square plus 2 and x minus 2 is 0. So now comparing this, what we either the x square plus 2 will be equal to 0 or x minus 2 is equal to 0. X square plus 2 equal to 0 implies as x square is equals to minus 2. Square cannot be negative, so it is not possible. So the value of x is 2 only and 2 is in the interval. Now we will check f double dash of 2. We have calculated f double dash. So replace x by 2. We get 36 into 4 minus 48 into 2 plus 24. After calculating everything, we get f double dash of 2 is 72. That is a positive. Now we get for 2, the second order derivative is positive. Naturally, it is a positive. It indicates that f of x is minimum at x is equal to 2. Now we come to know that the value of f of x is minimum at x is equal to 2. But what is its minimum value? To find out its minimum value, we will calculate f of 2. So every x should be replaced by 2 in f of x. By replacing this value as 2 in f of x, we get the value of f of 2 as minus 39. And this minus 39 will be the local minimum value. So we get the local minimum value is equal to minus 39 at x is equal to 2. Here we get only the one value of x because this x square equal to minus 2 was not possible. But if you get the x or one more value, for that value also we will check f double dash and we may get the minimum as well as the maximum value. Now this was a local. We have to find out the absolute because the interval is given. For that, first we will calculate f of 3. F of 3, just replace x by 3 in every x in the f of function f of x. By simplifying this, we get the value of f of 3 is 16. The minimum value was 0, so that is f of 0 we will calculate. And when we calculate, it means every x should be replaced by 0 in the function. We get f of 0 is 25. Now we'll try to find out the absolute minimum value. Will be the minimum. First, we get f of 2 was minus 39. This we get it as a 25 and 16. And minimum among all these three values is minus 39. So absolute minimum value is also minus 39 at x is equal to 2. We sometimes get equal to the local minimum value. Sometimes it differ. Depends upon the question. Now we will find out the absolute maximum value. That will be the maximum among all these three values only. What is the maximum value among this is 25, and that is at x is equal to 0. So absolute maximum value is 25 at x is equal to 0. So first we have calculated absolute minimum value is minus 39, absolute maximum value is 25, and the local minimum value was also minus 39 at x is equal to 2. So here we have calculated the maximum value, minimum value, that is a local, as well as the absolute values. Now we will go for one more sum. We'll try to understand by taking one more sum. Find the point at which the function f is given by f of x is equal to x minus 2 raised to 4 x plus 1 raised to cube, has a local maxima, local minima, and point of inflection. Now for that, as the function is given x minus 2 raised to 4 x plus 1 whole cube, we will first find out f dash of x. Now for that we have to use the product rule. So first derivative of the second plus second derivative of the first. So after simplifying, what we get, x minus 2 raised to 4, the derivative of x plus 1 the whole cube will be 3 x plus 1 the whole square plus x plus 1 the whole cube, and derivative will be 4 x minus 2 raised to 3. Now we have taken x minus 2 raised to 3 common, as well as x plus 1 square common. So taking these two values common, what we get from here, that is a 3 x minus 2 plus 4 x plus 1, that is a x minus 2 cube x plus 1 the whole square, 3x minus 6 plus 4x plus 4. So we get, that is a f dash of x is equal to x minus 2 the whole cube x plus 1 the whole square into 7x minus 2. Now after this is a first order derivative. We'll find out its second order derivative. Now for that UVW. So use again the product rule. First, second, derivative of the third bracket. Now derivative of 7x minus 2 is 7 plus second and third I have kept, and we have taken the derivative of x minus 2 the whole cube is 3x minus 2 the whole square, and then x minus 2 cube, and 7x minus 2 is kept, and we have taken the derivative of this x plus 1 the whole square, that is a 2 into x plus 1. Now what is a common we can get, x plus 1, x minus 2 square is a common, so that is a left 7x plus 1 into x minus 2 plus 3x plus 1 into 7x minus 2 plus 2x minus 2 7x minus 2. Now you can simplify this more, that is a multiply and simplify, but we can keep like this because ultimately we have to find out the values of f double dash, and it becomes easy. Now first f dash of x is equal to 0. As f dash of x is equal to 0, what we get, x minus 2 cube x plus 1 square, 7x minus 2 is 0. So either the x will be 2, or x is equal to minus 1, or x is equal to 2 by 7. Now we will calculate the second order derivative for first minus 1. F double dash of minus 1. When we replace x as minus 1 here, this becomes a 0. So 0 multiplied by any number is a 0. Same way f double dash of 2, that is a replace x as 2. This part will becomes a 0. 0 multiplied by any number is a 0. As we get for these two values as a 0, we will say that this test is not suitable to find out the local maxima and minima. That is a second order derivative test is not suitable. And so we have to use the first order test to find out the local maxima, minima and point of inflection. Now for that, we will check for every value of x and what happens with the f dash of x with the left hand side of that value and to the right hand side of the value, because the first order test says if it is a first order derivative left point and the right points, on that basis we are finding out the maxima and minima value. Now first we will check for 2 by 7 and we will try to find out f dash of 2 by 7 when x is tending to 2 by 7 but left of 2 by 7. What is mean by left of 2 by 7? We know that x is tending to 2 by 7 minus. So that will indicate that 7x minus 2 is less than 0. Now as this is a less than 0, when x is 2 by 7, when we replace x as 2 by 7 here, 2 by 7 minus 2, it is going to be a negative and its cube will be the negative. Now in the order, this is a negative, this is a negative, and the third part was x plus 1 the whole square, so it will be the positive. So ultimately what we get, this is negative, negative and positive, so ultimately we will get it as f dash of x is greater than 0 for left side of 2 by 7. Now we will think about the right side of 2 by 7. So when x is tending to 2 by 7 plus, naturally 7x minus 2 will be greater than 0. But x minus 2 whole cube will be less than 0. And x plus 1 the whole square is always positive. So it is a greater than 0. So ultimately your f dash of x will be less than 0. So initially it was increasing up to 2 by 7 and after 2 by 7 it starts decreasing. So what we can say, the 2 by 7 is a local maxima point. Next we will check for x is equal to 2. For x tending to 2 minus, it implies as x minus 2 is less than 0. So its cube will be less than 0. But when we replace x as 2, this is 14 minus 2, that is a 12. It means it is going to be a positive. So this is negative, positive. Ultimately what we get, f dash of x will be less than 0. And as x tends to 2 plus, what we get, x minus 2 will be positive, this is also positive and f dash of x will be the positive. First it was decreasing, then it start increasing, so this is a local minima. So x is equal to 2 is a point of local minima. Now for x is equal to minus 1, as extending to minus 1 minus, it means x plus 1 is less than 0, but as a square will be always positive. And this cube x minus 2, so when we replace x as minus 1, this is a minus 3 cube, so it is a negative. 7x minus 2 is also negative. So ultimately this negative, negative and positive, when we multiply, it will be positive when it is tending to minus. Now when we go, that is towards the left side. Now right side, as x is tending to minus 1 plus, x plus 1 is less than 0, but square will be positive. This cube is negative. 7x minus 2 is a negative. F dash of x is a positive. So there is no change in the sign of f dash of x at x is equal to minus 1. And thus x is equal to minus 1 is a inflection point. So we have calculated the local maxima, minima and the inflection point. And here we complete the theory of the approximation, maxima and minima of a function by using the application of derivative. So you can solve the remaining exercise, that is a 6.4, 6.5 and miscellaneous. And for that the links of this is given as follows. You can visit and check your answers. Thank you, students.